Hello everybody, glad to see you. Today we're going to talk about position control. As we can see at top left, we are going to have this positioning control. We are going to have cylinder with a diameter of 0.5 back to A, B, C. A is this plane, B is this plane, and C is this plane. We are going to fix this component by sitting on A and B in contact with B and also C. In that way, we are going to have a cylinder with a diameter of 0.5 perpendicular to A, and the axis of this hole should be in that cylinder. Let's see this example. We have used this positioning control here. We are going to have cylinder with a diameter of 0.2 back to A and B. A is this plane and B is this axis of this hole on left hand side. We are going to have this yellow area, this cylinder with a diameter of 0.2. It should be perpendicular to A, and axis of this hole should be in that cylinder. And we have used basic dimension between these two holes, and in this way we are going to control the location of this hole respect to another hole. As we can see here at the bottom, for different situation, whenever the second hole, or the hole on right hand side is going to rotate, it should be in a way the axis of that hole should be in the yellow area, as we can see here at the bottom left or at the bottom right. We can see here if it is going to rotate, the axis of this hole should be in that yellow area. Here again we are going to use this positioning control. We are going to have cylinder with a diameter of 0.2. We are going to control the axis of this hole respect to A and B. A is this plane, B is the axis of another hole. And we have another limitation here. We have projected TZ for the length or height of 40. We need to control the extension of that axis out of this hole with the height of, let's say, 40. Now we have two limitations for the bottom and for the top, for the hole and for the extension of that axis with the, let's say, here with the length of 40 or height of 40 here. For different configuration, we should satisfy both conditions for bottom and for this extension axis for this projected TZ as well. Let's see this example. We are going to have two here by this FCF. In horizontal direction, we are going to have TZ 1.5 back to A, B, and C. And also here, we have two for both holes. And here, we have TZ 0.5 back to A, B, C. What does it mean? As you can see here, on the right hand side, we are going to have these two hash area. In X direction, we are going to have 1.5. In Y direction, we are going to have 0.5. In this way, we are going to control the orientation and location of these two holes. Here we can see we don't have any diameter symbol. That's why we are going to have two parallel boundaries. At bottom left, we can have these two independent FCF. At top is the same as that one, but we have 1.5 here. But for the bottom, we don't have C here. Both of them, they have exactly the same meaning. For top, we are going to have 1.5. It means we are going to have, let's say, this square with the size of 1.5. But for bottom, we are going to have more limitation. We are going to refine it. We are going to have 0.5 respect to B. If we are going to make offset respect to B, it should be 0.5. That's why both of them, they have exactly the same meaning. Let's see the last example for today. It is Composite FCF. We have just one symbol for both of them. The first one, as you can see, we are going to use this diameter symbol here, 1.5 here, back to A, B, C. It means we are going to have a large cylinder with the diameter 1.5, and it is highlighted here. It should be perpendicular to A, and center of this hole should be in that interval. But we are going to have another limitation here. We are going to have a small cylinder with a diameter of 0.5 back to A. It means this small cylinder can be in that large cylinder, and in this way we are going to control the orientation and location of these two holes. Here at the bottom left, we have add reference plane B for the bottom. What is going on here? For the top is the scenario 4. We are going to have this large cylinder, and then the center of these two holes should be in that one. But at the bottom, we are going to have a small cylinder, the diameter of 0.5, back to A and B. What does it mean? We are going to have B here. It means this pattern, this dashed line cannot be rotated respect to B. Whenever we are going to have this small cylinder, somehow it means we are going to have this offset respect to B. It should be in that small cylinder for both of them. And center to center of these two small cylinders should be parallel to B. It cannot be rotated. Somehow we are going to control this pattern. We are going to have more limitation when we are going to add this reference plane B here. For now, I would like to close this session. In coming session, again, I'm going to talk about position control. Thank you for today. I hope you enjoyed. See you next time.